Done.
Welcome to yet another exciting experiment with SA Science Spotlight podcast. We are here at the UP Physics Department and today we are going to show you the redox reaction. I am honestly excited and do not forget I am not alone. Today I am yet again with our Tepo, who's the Tepo the scientist, not the other one. Tepo. The other Tepo, you know, guys, he uses cleaning things to demonstrate our experiments. But today we are actually going to be doing an experiment that I've actually studied in high school. So if you were in grade 11 or you were in grade 12 or you are now in varsity, you know that we were taught about inorganic chemistry. And this is yet another experiment that is going to teach you more about it. But now you're not only learning on study materials only, you're actually going to be able to see what happens in this experiment. Tepo, can you please tell us more about this experiment?
So as we've said, we're going to be doing redox reaction, which is just a combination of reduction reactions and oxidation reactions. Yeah.
So what's the purpose of this reaction? Why do we do it?
Remember last time when I was here, I talked about how every time we understand something, it brings us a bit closer to different applications, right? So for this one, it has brought us stuff like electrolytic cells for coatings and also galvanic cells for batteries. So these are just
Another thing that this experiment reminds me of is when you have a spoon. You have noticed that inside the spoon it's actually copper, but it is coated in silver on the outside because it is known that silver doesn't oxidize as quick as copper does. So if an object is coated with silver, it means it's going to last longer than if it was just only copper. So copper is going to oxidize faster than silver does. So I hope you get a bit of an explanation and an understanding of what this reaction is all about, okay? Yeah. So what do we have as our ingredients? Yes.
Yeah, so the reagents today that we'll be using, it's just simply silver nitrate and a simple copper wire thing. So this one, copper wire. So the idea is we're going to show how copper will be coated with silver, right?
How copper will be coated with silver. So silver nitrate is standing in for the silver.
Yeah.
Oh, okay. But why is it invisible, this one?
It's not invisible, it's just clear.
It's just clear.
Yeah. In there we have like ions.
Okay.
So in there we have like silver ions plus nitrate, right? Nitrate ions. So those ones are the ones that are going to, the silver ions are the ones that are going to come out of solution and then coat around shell. And then the copper is going to go into solution. So basically it's going to corrode.
Corrode.
Yeah.
Oh yes, the word corrode. Yeah.
It's going to break down into into the solution.
Okay.
So if you see it. Sure. So now we're going to add the silver nitrate into the test tube and then dip the copper wire. Just enough.
Why are you wearing gloves?
Oh, this is a very dangerous chemical.
Okay. So you understand it, you have to wear your gloves. It's a very safety matters.
Yeah, so this reaction is very, very fast. So as soon as we dip the copper in there, it starts reacting. Huh?
Oh, it's now going black.
Yeah.
It's no longer coppish, like copper.
So if the copper was clean, it didn't have any oxygen on the outside, this will be like white.
White.
Like that. But because there's some oxygen here, it's basically starting to undergo rust. Yeah. Okay. So now it's black. But eventually it will become like this, where it's just silver on the outside. Yeah. And then the solution will also turn blue because of the copper now is dissolving into solution.
It's dissolving into the solution.
Yeah.
Oh, okay.
So the reaction itself, it's there on the whiteboard, where, as I've said, we have the silver nitrate dissolved in water to form silver ions and nitrate ions, right? And when you add the copper wire, they break down, the copper wires break down into copper ions plus 2 electrons, and then the silver ions will take 2 of those electrons to form silver metal. That's the one coating around the copper wire. And then what basically happens is just the exchange of these 2 metals. One going into solution and then the other one going out of it.
Okay.
So the blue solution that we will see eventually there will be this one.
Which one?
The copper nitrate.
The copper nitrate.
Yeah.
Oh, okay.
The blue solution. Plus the coating, the crystals.
Okay.
That's the fun part.
I see. Okay, so I also see that you have some other things here.
The other redox reaction, the fun one, it's the reduction of potassium permanganate.
Oh my god, do not put me on the spot because it's been so far.
Yeah,
okay.
It's potassium permanganate.
Yes.
This one. Right? So this one more concentrated. Let me dilute it in water, distilled water. Sure. And we're going to add sodium hydroxide in there. Right?
Sodium hydroxide.
Yeah.
Okay.
So what we'll see, it's multiple color changes.
Okay.
Right? It's the reduction of potassium permanganate, right? In our basic solution. See the color changing. The color changing. So it was
Now
purple,
it's-
it was purple, and now it's becoming green.
It was blackish, but now it's greener.
Yeah. So if you stir the sugar, you see it going transitioning basically. See, green, and eventually will go yellow, and then finally brown.
Finally brown.
Yeah.
Okay.
So that's the reduction of potassium permanganate, right? It's basically potassium permanganate like this one in solution, potassium permanganate, and then it will undergo reduction. So all the 2 oxidation states, basically the manganate,
It's not changing to yes.
Yeah. So all these color changes, it's basically different oxidation states of the manganese. Yeah. This one is fun. So normally people on the internet, they do this with lollipops.
Lollipops.
Yeah.
Why lollipops?
Sugar.
Instead of sugar, they use lollipops. Oh, okay.
Glucose.
So what is the function of glucose, sugar in this experiment?
It's the source of reducing agent.
Source of reducing agent.
Yeah, so it's reducing the potassium in the presence of sodium
hydroxide.
Basic condition, basically.
No, it looks like Coke. Now it's making me hungry.
Yeah. So as I've said, the applications here are like immeasurable, because with this you can create cells, batteries, if you can control this. Because remember there's flow of electrons, right? Like flow of electrons. So every time there are electrons in a reaction, then it means we can manipulate them, right? Yeah, we can manipulate them so that basically control the reactions. So one way is to either put electricity in here. If you add electricity, then you have something called electrolytic cells, where that electricity will be turned into chemicals. That's the coating.
That's the coating.
Yeah.
And I also remember, also in grade 12, they also teach the difference between these two when they're teaching electrochemistry like this. Yeah.
So one side is conversion, energy conversion, where you go from electricity to chemical energy. And then the other side, it's the galvanic cell, where you control the reaction in such a way that it generates electricity. So you're basically converting the chemicals into electricity. Yeah.
And that is it, guys. I really did enjoy the experiment because it actually also brought the knowledge that I already have into life. Like, I'm actually seeing what I was studying when I was in grade 11 and 12, and I hope it was as helpful to me as it was to you. So if you have found this experiment helpful, please comment on your favorite part of the experiment, and also do not forget to subscribe to our YouTube channel. Follow us on all our social media platforms. We are on TikTok, we are on Instagram, we are also on Twitter. So this is it. See you on another yet exciting experiment.
Cheers.